We'll see about loop statements. So before we proceed, we'll see what is loop. Now, you'll be having in a program some set of statements, and these set of statements will be executed sequentially. When you start the program execution starts from the first line. So after executing first line, then it will execute the second line, then the third line, fourth. Sequentially from first line to the last line, it will execute. It will never jump from one line to another line. In the previous chapter, that is in branching statements or conditional statements, we have seen using an if-else switch, we were able to jump in a forward direction. That is, from second line, you can jump to a fifth line like this. Okay, that was a forward jump. Okay, so once it jumps to this fifth line, from there again it will continue sequentially execution. Okay? But on its own, always the execution will be sequential. So it will never jump from one line to another line directly. So after executing first line, it will always go to the second, and after second, it will go to the third. After the third, it will go to the fourth. But if you want, you can jump even in a backward direction. So what happens when you jump in a backward direction? Let's take in a program you have some set of statements. So this is the first line, second, third, fourth, okay, and fifth. And in fifth line, I'll using some statements, I'll make it to jump in a backward direction, that is to a second line. So there are statements to jump in a backward direction also. So now you have executed the first line, the second line, the third line, it will execute fourth, if it will execute fifth. So in fifth, you said go to line number 2. So it will go to the line number 2. Again from line number 2, it will restart execution. So again it will execute second line, again third, then the fourth, then the fifth, and then again go back to again second, then again second, third, fourth, fifth. That means these set of statements will be executed more than once. In a program, when a set of statements executed more than once, that we call it as a loop. So what is loop? A loop is nothing but a set of statements which are executed more than once. So to do this, we have to jump in a backward direction. Okay, we need to jump in a backward direction. Using this if-else, if switch and all, we used to jump in a forward direction. Whereas in this chapter, we'll be studying the statements through which you can jump in a backward direction to make it as a loop. So for doing this, C language provides you some set of commands. So one is goto, second one is an while, then do while, and for statement. These are the 4 statements through which you can make it a loop. Okay. Apart from these 4 statements, to control, we have another 2 more statements. One is an continue and second one is an break. To control the loop, you can also use this continue and break. So these are the statements which we'll be studying in this chapter. Now, what is the need of jumping in a backward direction? Okay, what is the need of loop? So to explain this, I'll take an example. That is, I want to write a program to display a natural number from 1 to 5. So first we'll do it without using a loop. So here we'll discuss about what is the need of making the set of statements executed more than once. That is, what is the use of loop. So I'll write a code here to display a natural number from 1 to 5 without using loop. First we'll see without using loop, and then we'll rewrite that using loop. So I'll take directly the main function. Now I have to display a natural number 1, 2, 3, 4, 5. So for generating this, I'll take and declare a variable here, that is an I. And this I variable, first time it has to be an 1, so we'll initialize it, I equals to 1. And then that 1 has to be displayed, so we'll take up here as printf/n, that is bring the cursor to the new line and then display that I value, that is an 1 is displayed. So 1 has been displayed. And then next is we have to display 2. So at present this I variable value is 1. So that 1 has been displayed. Now I have to display 2. So naturally this I value should get incremented by 1. So you can give here I equals to I plus 1, or else you can just give here I plus plus. This I value will be now become 2. And then display the 2 by giving here printf slash n percentage d, that is an I variable. So now it will display I value is nothing but 2, so 2 is displayed. Same way again, next time I have to display 3, then you increment I value by 1. So I plus plus, this I variable will become now 3. And then the 3 has to be displayed. So I'll give a printf slash n percentage d and then give her I, so the 3 is displayed. So got to display now 4, so give her I plus plus. So this I variable value will become now 4, and display that 4 by giving her printf slash n percentage d then I, so 4 is displayed. And now next I have to display 5, so again give her I plus plus. So when you give I plus plus, I value will become 5, and then display that I value here percentage d, that is I, so this 5 is displayed. And now you can stop. So this is a simple program to display a natural number from 1 to 5. Now how many lines of program we have written here? We'll just consider only the statements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code I have written. Okay, 11 lines of code I have written just to display 1 to 5. But the same thing if I wanted to display here 1 to 100. Okay, 1 to 100, naturally my length of the code is going to be 201 lines. Why? Because one is you have to increment the value, that is by using I plus plus, and then I have to display the data. So that means to display each data I need 2 lines. So that means 100 means 200 plus this one initialization or declaration, all that. So total it's going to be nothing but around 201 lines of code. Same thing if I want to display 1 to 1000, then I have to write a code of 2001 lines of program. Okay. So as my data increases, my code, the program length also gets increased. But if you observe this here, you can check out this I plus plus and printf. If you observe, it is getting repeated more than once. So you can take up like this, printf I and then I plus plus. These 2 lines are getting repeated more than once. Now what is the difference between this set and this set? Printf percentage di I plus plus, printf percentage di I plus plus. There is no change in this set. So if you have add one more I plus plus, it doesn't make any difference. Now there is no difference between this set and this set. So that means all are same. Then when it is same, why we need to type this multiple times? What we'll do is we'll write it only once by giving here printf percentage d, that is an I, and then here I plus plus. I'll write it only once. And what I'll do is I'll make it go back and then keep on repeating this. So to do that, we have a statement, something called as an go to. But for go to which line you have to go, that for that particular line you have to give an name. Okay, so for this printf line, I'll give a name. So we call this as a label. So label has to be given like this. Any identifier can be given. I'll give it as an XYZ, and then you have to give an colon. So that means for this printf line, I've given the label as XYZ. So that from here, after incrementing I plus plus, I value, so I can specify here, go to that XYZ line by giving here, go to XYZ and then give semicolon. So it again goes back to this place. So now what we have done is, instead of writing this set of statements more than once, I have written it only once, and I'm jumping in and backward direction so that it keeps on repeating this printf and I plus plus multiple times. So if I take up a complete whole program, the whole program looks like this. So we need to declare variable I, and that I value has to be initialized. So we'll give her I equals to 1, and then we'll close the program here. Let's just analyze this, how this program is going to work here. Okay, so we have declared an I variable. So we have declared an I variable. So 2 bytes has been allocated for this I, and then we have initialized here I equals to 1. So first time I value is equals to 1. Printf I, so 1 is displayed. After displaying 1 I plus plus, this I value will become now here as an 2. Okay, I value is 2. And then I said here go to XYZ. When I say go to XYZ, it goes to this XYZ line where you have a printf statement. So you have given a printf I, so that I value is now at present 2, so 2 is displayed. And then again I plus plus, so I value will become now 3. And then again after incrementing, go to XYZ, again it goes back to this XYZ line. So when that means I'm going in a backward. When I go backward, this printf I plus plus is executed more than once. So now when it goes back, again printf I value is at present 3, so 3 is displayed. Then again next time I plus plus, I value is 3 now, it becomes here now 4. And then again go to XYZ, again goes back to this XYZ line, and then printf I, so 4 is displayed. And then again I plus plus, I will become now 5. I will become 5. Again go to XYZ, goes back, again printf I, so 5 is displayed. Again I plus plus, it becomes now 6. Then again go to XYZ, it goes back and then displays 6. Then same way 7, 8, 9, 10, continuously, it will not stop. Okay, the program will never get terminated because it is an infinite loop. We have blindly specified go to XYZ. It will never come down to next line at all. So of course there are statements to control. If you want to display only 1 to 5, I can make it display only 1 to 5, and after that immediately I can make it come out. Okay, there are statements, but not with an go to statement. We'll see about that in detail. Now what happens here is this printf I and I plus plus set of statement, these two lines are getting executed more than once, including this go to statement, So these three lines, that is printf, I plus plus and go to, is executed more than once. So in this program we call this as loop. So what is loop? A loop is nothing but set of statements executed more than once. Now if I want to display, it will display from 1 to 32,767. Again it will start in a negative values. It will never stop. So to display 1 to 30,000 or 32,000, how many lines of code we have written here? We have written here only 3 lines of code: printf, I plus plus and go to XYZ. So one thing is, here it will not stop. We'll see how to make it stop. By using this loop, we are reducing the length of the code. So if I want to display 1000 in the previous case, in this case, then I have to write here 2001 lines of code. Whereas here, if my program, that is number of data to be displayed, if it increases, my program will not get affected. Okay, that is the advantage of loop. Fine. So what is loop? A loop is nothing but a set of statements in a program which is executed more than once. We'll see in detail one by one the statements. But usually in C language, they won't prefer to use an go to statement. You'll come to know in functions chapter why exactly you shouldn't use an go to statement. I'm not going to explain any programs using go to statements. Okay, I have just shown you one, how to use and go to. There are other 3 more loop statements, that is an while, do while and for. In detail we'll discuss about that, and also we'll be solving many programs using each of these statements. I hope you have understood what is loop. We'll continue with one by one loop statements.